All right. Thank you, Brandon. Hello, folks, and welcome to another great webinar in this series of webinars we've been doing here at Perfect Scale by Do It, where we invite exciting folks from the industry to talk about exciting new tech. And today I'm very happy to have with me Arsh Sharma, who's the senior DevRel at Metal Bear. And Arsh, I'm really happy I finally have you here because we've been, talking at conferences for the last 3, 4 years,
Mhm.
and finally we're collaborating on this exciting content. And uh, I'll let you share your screen and tell us all about what you're going to present today.
Thank you for the intro, Anton. I'm gonna start my screen share, and we have a lot of interesting content to cover. And let's just get started right with it. Okay. So the webinar is going to be about
We
how
still, we
you
still
can.
don't see your screen.
You don't? I am sharing it.
Oh, wait a second. Okay. Yeah, okay. Different view. Okay. Yes, we can see the screen. It's fine.
Cool. Yeah, so the webinar today is going to be about testing AI generated code in Kubernetes. And I wrote a blog post about this and I was sharing it in places and I started getting a lot of like suspicious eyes and even accusations about, how that will break down clusters and that just sounds like marketing bait and gimmick and that's not possible and all of that, which I agree. Like if you tell anyone that, we are going to deploy AI generated code to Kubernetes clusters, it is going to sound bizarre. But in this webinar, we're going to learn how you can do that in a safe way, how you can test AI generated code in Kubernetes clusters, but without actually deploying them and without the risk of breaking the cluster. Also, let's be clear here. When I talk about testing AI generated code, we are talking about, as soon as the AI generates the code for you, instead of going through the traditional dev loop, you are able to directly test it on a cluster. So let's see what the traditional or what the current AI development workflow looks like for most people. And let me know in the comments if you are doing something similar or if your workflow looks different. So right now, what most people do is you'll be using Cursor, Codex, or one of the 1,000 AI code agents and editors there are to generate some code. And then once that code has been generated, you will, glance through it manually and you will maybe even run some local unit tests. And if they pass, that's a good thing. If they don't, that means the code was like really bad. But usually unit tests pass because AI is able to, read your unit tests and sort of write code that way. But the problem becomes when you try to do integration or end-to-end testing because AI does not have the context of your broader application of all the microservices part of your application. It can read the code of one particular microservice and the unit tests for that microservice, but it generally does not have an idea about what the entire application looks like. So to do that, you rely on CI pipelines and staging clusters. But the thing is that the code AI has generated, like it's on your local machine, right? So that means you have to commit it, you have to build a container image. If you're using ephemeral environments, then you have to provision those environments, which could be actual Kubernetes clusters on cloud providers or local Kubernetes tools like Minikube and Kind. And then you have to deploy those container images. And all of this takes a lot of time. Like if we are being like, it would easily take 15 minutes, and usually it takes more than that when you sort of go through this loop. And the problem is that you don't have to go through this. If you have to go through this once as like a validation or final check, I would still understand, like it's okay. It's like a one-time thing. But when you go through this and you find out that the code AI generated and sort of you wrote or you validated, there's something not working, then you go through this entire loop again where you will ask the AI agent to make iterations. And then again, you have no way of testing out those iterations. So you go through the process of building the container image again and deploying it and all of that. So each developer ends up going through this like multiple times for a single, fix or a single feature. Um, So I feel like the bottleneck in this process is the fact that you had to build container images and you had to wait on pipelines and deployments. If there was a better way to do this faster, like as soon as the code has been generated and you're able to end-to-end test it or do integration testing on it, then you would save a lot of time. So this is the loop I want to propose. This is the loop which we are trying to, get people to try out, which is that you write code using an AI code editor, and then you test that code, including end-to-end tests, integration tests, and all sort of tests in a production-like environment with the entire context of, what production looks like. And then if things fail, you iterate on it, and then you can simply test that code again. But here there is no, you are not committing your code, you are not building container images, you are not creating clusters or anything like that. You're just able to connect to an existing shared Kubernetes cluster, which your team already maintains, which is usually the staging cluster or the pre-prod or testing cluster. And you're able to leverage that to test code as soon as it gets generated. And once you have gone through all of this, you then just go through the final step of, the final validation step, which was part of the original previous loop where you build the container image and deploy and all of that. And at that point, that's just a sanity check because you know that if your code is working like this, it will work on the staging cluster as well. So the
Yeah.
biggest question here, sorry.
Yeah, yeah, I forgot to say this in the beginning. I saw Brandon wrote it, but folks, if you have any questions whatsoever about the content that Arsh is presenting or about Mirrorly, yeah, I see somebody already sent a question. So we have the Q&A section. Please feel free to send us questions. Yeah, Arsh, please continue.
I see a question already. Why are we highlighting AI generated code specifically? I assume it's useful for testing regular code development as well. Yep, that is true. And the reason we are highlighting AI generated code is because uh, so it's related to the fact that these days like the bottleneck has shifted from being able to generate code to being able to better test it and better integrate it into your existing code base. So you can do this for code you have written as well. It's not something which is limited to AI generated code, but it's just that AI has enabled us to generate code and create more code than before, which is why this becomes, being able to test AI generated code faster becomes even more relevant. And that's why we are talking about this. But you're absolutely right. It's not limited to AI generated code at all. Um, so yeah, the question becomes then,
One more thing I would add is probably once you have like a good testing setup, you can basically allow your AI editor to run the tests itself, and it's quicker than running tests manually.
true. We have been experimenting with this. If you go to our blog, we have been, giving Claude access to Mirrord, which is what we're like, which is the tool we are building, which allows you to do this. And we have
Mhm.
seen it, use the tool to test itself, like the code. But yeah, we'll get to that when we get to the demo section. But yeah, I've been proposing this idea, which might feel very radical, that how are you able to test out the code you are writing without building container images or without deploying it? And the answer to that is an open source Kubernetes development tool, which we have been building at Metal Bear called Mirrord. What Mirrord does is it lets you run your local code. It lets you run your code locally, but in the context of an actual Kubernetes environment. So it's almost like your code thinks that it's running inside a production cluster, but it's actually running on your local machine. But Mirrord takes care of mirroring all the traffic, environment variables, file system between your local process and the cluster itself. So this allows you to, test your code as if it was in the cluster, but without going through the hassles of building a container image or provisioning an extra environment, because you're able to leverage an existing Kubernetes environment, which you are already running and which is usually a replica of production. So maybe staging or testing environment, which you have. So like I said, the application would run locally on your machine, but all the let's suppose you're working on microservice A, and the staging cluster you have has microservice A, B, and other dependencies deployed. So you would run the code you have written for microservice A locally, while your microservice would be able to talk to the other microservices and databases, queues, and whatnot, which are already there in the cluster. So you don't have to create them. And any traffic which is coming to the microservice you're developing in the cluster would get mirrored to your local machine. So you can see how your local code would behave when it receives traffic. So this is a diagram basically showing what I just said, where you have a process you run locally on your machine, and then you connect to the same microservice for which you might have written code in the cluster, and then Mirrord takes care of mirroring incoming and outgoing traffic, and taking care of communication with other services and databases in the cluster. I'm just gonna pause to see if we have any questions so far.
No, no. If we have questions, I'll tell you.
Okay. Perfect.
So you
Yeah.
can present fully.
Um, So the idea is very simple that with Mirrord, you can, mirror incoming traffic which is coming to the cluster. So we see that any traffic which you send to the cluster's endpoint, that would get mirrored to your local machine. But you can also, any traffic which your locally running process on your machine, makes, so any requests to other services or the databases, that would get mirrored from the local machine to the cluster. So you are able to talk to all the dependencies that your microservice needs to talk to. And then you can also steal the traffic instead of mirroring. So any traffic which is coming to your service would just go to your local process instead of the counterpart here. And at the same time, you are able to access all of the environment variables which are there in the pod or the relevant deployment of the service which is running in the cluster. And you also have access to all the files which are there in the cluster, which we'll see in the demo as well. So all of this, basically all of this, what it leads to, what it boils down to is that you are able to test your code in a production like setting without going through that tedious loop, which we talked about, which took like 15 to 20 minutes each time you went through it. So that was enough talking about Mirrord. I think Mirrord is best explained when we see a demo. But before we get to the demo, I think it'll help if we just walk through the demo application. So the application we have here is an IP visit counter application, which basically when you send it a request, it shows the IP the request was received from and some details about it. And it also shows how many times a request has been sent from that particular IP. So behind the scenes, this application is made up of 3 microservices. So there is the IP visit counter service, which is like a main front where the request is received. Then this service saves the IP to Redis. Then it pings the IP info microservice, which has some IP stored and returns info if the IP is stored. And if it's not stored, it returns a generic message saying unknown. And then finally, we have another IP visit consumer service, which the IP visit counter service sends messages to a Kafka queue, and the IP visit consumer consumes messages, and this is just for logging purposes. So you can see it's not a very complicated setup, but it's a demo app. It's meant to show that, applications these days have a couple of microservices, they have databases, queues, and all of this stuff. And if I were to, if I were to write some code for the IP visit counter service and I want to test it locally, I would need a way to talk to Redis, Kafka, IP info service, and running all of these locally. First of all, it would not match what they, how they run in production, and I would not be testing accurately. And second of all, it's just really annoying to have to set up all of this each time I want to test. So we'll assume that, our organization has deployed this application in a staging cluster for testing purposes. And we'll generate some code for this application. And we'll test that code in the context of the cluster, but without building any container images or without even committing our code. With that said, I see one question in the Q&A.
Okay, go ahead. Yeah, it's
Um,
relevant, I guess, to what we're
yeah.
doing.
So how careful you need to be, since if anything goes wrong while testing your code can affect multiple services. So that's the point, right? Like you are not sending your code actually to the cluster. Mirrord only mirrors traffic, files, and all of. the stuff to make your local process think that it's running in the cluster, whereas it's actually not. But when you're talking about, your code affecting multiple services, I guess you're talking about, what if your code writes to a database or something like that. So Mirror allows multiple developers to safely develop using the same cluster. So we have features like database branching and queue splitting, which allow you to, like control, make a copy of a database so that you don't write to the actual staging database. And then we also have guardrails like Mirror policies, which prevent users from writing to certain sensitive databases and all of that. And let me just show you the demo, and I can circle back to this question if it's still left unanswered, because I feel like it'll be useful for you to see how Mirror works and then talk about how Mirror works in a shared environment.
Okay,
So that was, I hope the demo app is now clear. Let's just switch to cursor now and see the actual demo.
great to the
Where
demo
should
gods.
Yes, pray to the demo gods. So these are the services I have. I am currently in the IP visit counter service, and what I have installed is the Mirror extension, which comes for all code editors, VS Code, JetBrains IDEs, any VS Code force folks like Cursor, Windsurf. But if you don't want to use the extension, we also have a CLI which you can download. I'll be using the extension because it's super easy to use, and I prefer that way. So once you have the extension installed, you need to select an active configuration, and we'll select the configuration for the IP visit service, which I already have selected here. And then I'll just click on this circle to enable the Mirror extension. And after I've done that, I am going to add a breakpoint somewhere, maybe in my main function where I'm loading configuration. So right now I'm not generating any code. I'm just showing you how basic mirroring in Mirror works. So after that, I go to run and debug, and I'm using my IDE's debugger, which is one of another good things about Mirror is that you don't have to change your workflow. You can, use your local debugger and local coding tools, and it works with all AI coding assistants. So you can use the stuff you like without having to, change the way you work. So I'm just running this process now, and it is up and running. So we can see in our debug console. But what I'm going to do is I'm going to shift to my terminal here, and we'll see that I can send, so this application which we were talking about, right? It has been deployed at this endpoint, playground.middleware.dev. And all of you right now can also go and, send a request and see that it works. But we'll send a request and see what happens when our process is running. So you see that we get a response where we get account is one, and our IP is shown, and we see the text remote is one. But also what happens here is that our breakpoint gets hit. So you can see that our breakpoint is hit. And now we can step into this load config function here. And you see that this load config function is basically creating some environment variables and reading the values of those variables. So if I go through all of this here towards the end where we are about to return our config, and I read the config which gets created, you'll see that I am reading all of these values from stuff which is there in the cluster. These are environment variables which have been set in the Kubernetes cluster. And we can see that here in my, like, if I see that, like I'm connected to my staging cluster as well, just to show you that. And here I can see all these services which we saw in the diagram of the demo application. We can see that they are all deployed in the cluster stake. So you can see that the font is, I think, too big, so it's not being displayed properly. But you can see that there's the IP info pod, there's the IP visit consumer pod, and basically all of this stuff, including Kafka and Redis, have been deployed in the staging cluster. And so here we see that all of these environment variables get populated from the things which were there in the cluster. I want you to pay attention to this response file, which is at app.response.txt. This is not present locally on my machine. So if I do an ls, this is not here, okay? So this file is there on the cluster. And we'll see that once we step out of this and we go a couple of steps down here, the config tries to read from app.response.txt, which I don't have on my machine. And when we go a couple of steps more down, we see that it is able to read the contents remote is fun from that file. So this was a file which was there in the cluster, and our locally running process is able to read the contents of those file, and our code is able to, behave like we want it to behave. And that's true because if you see here, right, this is what we got here, remote is fun with an high appended to it, which we manually append in the code. But yeah, this was how basically MirrorD works. So we sent a request to our staging endpoint, and that request got mirrored to our locally running process, and we were able to attach a debugger and see how, all the values in the locally running code got populated with stuff which was actually there in the cluster. So I'm going to stop this debugger and just wait to breathe and see if people have any questions so far.
Nope. Looks like there are none yet.
All right. Cool. So let's go to the next step of this demo. And
Yeah.
what we saw here was that we were sending a request to our endpoint, which was playground.metalbear.dev. And that request was like the response for that request was being sent by the service which was there in the cluster, while that request was mirrored to our locally running process as well. Now, what we want is to maybe, we have been asked to improve this particular service. We have been asked to make a code change here. I see a question on the Q&A.
How file contents are being read.
That is what is being handled by MirrorD. So MirrorD takes care of MirrorD spins an agent in the cluster, and then it takes care of mirroring the like when the request is being sent to read that particular file. MirrorD proxies that request to the cluster and reads the contents and then sends the response back to your local machine, and that's how the contents can be read. What kind of run config environment variables would be needed to configure in the mirrord in the IDE? I'm not sure I understand your question. You don't need to configure any environment variables on your local machine, like I said, because they are being read from the environment variables in the cluster.
Now, maybe what he meant is like, in order to form your D to know which cluster to access.
Oh, okay, yeah. I was gonna get to that, so I'm gonna show you the configuration file for mirrord right after this. Um, where are we configuring that only the traffic intended to? Um, yep, great question, guys. Whatever questions you're asking, I'm gonna soon show you how that does. So basically, yeah, we will see how you can mirror traffic just to yourself and not to everyone else. Do we need any component agent on the cluster? If you're using the open source version of MirrorD, which is intended for individual developers to work with a cluster, then you don't need anything on the cluster. You just need the extension and you need the kube config for your cluster. But if you want to use MirrorD in a shared environment, so that is multiple developers use MirrorD with the same cluster, which is how most people use MirrorD, then you need to install the MirrorD operator, which comes as a Helm chart, and you can learn more about this on our docs. Local environment is in a container. No, this is not in a container. This is cursor and the code was running locally on my machine. How is MirrorD different from dynamic instrumentation in Datadog? So I actually have no idea what dynamic instrumentation in Datadog is. Andon, if you know, maybe you could help out with this
No,
one. But if not, I can,
I've heard
just
about it.
reach out, send me an email. I'll give you my details and I'll answer this after checking in it. So yeah, a lot of people were asking about, how does MirrorD work? How do you configure MirrorD? So this is a simple JSON file, which by the way, you can also now have like ChatGPT generate it. And also we launched like MirrorD AI agent skills recently. So you can use like Claude code and help it read your code and generate this file for you. But it's fairly simple. So basically, you give it the namespace, which is the IP visit counter namespace, and you give it the deployment. So basically, any requests reaching this deployment would get mirrored to our local machine. If you can also choose specific pods, and if you don't specify this, MirrorD would give you an option to pick what requests, requests coming to which deployment do you want to be mirrored. But the part I want you to pay attention to here is the mode mirror, which was basically mirroring our requests, but the response for our request was still being sent by the service, which was there in the cluster. Now, what we want to do is, first of all, we want to, we have been given this task to add more, information for the user, right? So if we see here, when we send the request, oh, my bad. So when we send the request here, we only see a couple of fields, right? Like count, info1, info2, and some text. So we want to make the app more comprehensive, and we've been asked to add more fields to this response to give more information back to the user. And I am all in on this vibe coding thing, so I'm not going to type the code for this myself, and I'm gonna use cursor and say, um, add more information in the response for the IP visit counter service. Add more information, which let's just, we don't want random information. Add more information which will be useful for the user in the response of the IP visit counter service. And I'm going to give it this prompt and let's see what code it comes up with. Hopefully, it will not break the entire thing.
Yeah. Now we also need to pray to AI gods, not only the demo gods.
Yeah. AI gods and the Kubernetes gods. All
What up,
right.
guys? Great.
Here we go. So we have a lot of fields. I see it has added time to live. It has added a timestamp and a bunch of other stuff. So I'll be honest, I did not write the code for this application, and I do not know if this code it has written works or not. But the good thing is that we have Mirror which will allow us to test out if this code is actually working or not. So once this code has been generated, right? Like if you were not using Mirror what your workflow would now be is that I'm just gonna cancel this. What your workflow now would be is that you first of all like go through this, maybe run some unit tests, but after that you have no way of testing this out, right? Because if you were to test it out on your machine right now, you would need to bring up the other two microservices. You would need to spin up Redis database. You would need to spin up the Kafka component. And even after all of that, you would not have that, like these are all examples of this particular application, but I hope you understand that in the broader context, when you are developing actual applications, these things matter much more. But like you saw that we were reading text from that file, right? Remote is fun, all of that. So I'd have to create that environment locally, or I would have to commit my code and wait for a script in CI pipelines or a deployment to staging, all of which takes a lot of time. So, but here now that we have this code, we can use Mirror. And since we want to test out the response, and we saw that earlier when we were using Mirror in the mirror mode, the response was still being sent out by the service, which is in the cluster. Whereas we want our locally written code to be the one sending that response. So what we will do is instead of mirroring the requests which reach our cluster, we are going to steal the requests. But the problem with that is that if you're using Mirror in a shared environment and you start stealing requests which come to a particular service, then you would end up breaking the workflow for other developers who are using your staging cluster, which is not what we want because we want to be able to use a shared environment instead of, having per developer environments, which are really expensive. So what we do here is that we add an HTTP filter here, and that HTTP filter can just be, yeah. So we add an HTTP filter here, and that filter is just going to be my name. Actually, I have this already here. Maybe I'm just gonna discard. Um, yep. So I have the HTTP filter where I'm using a filter which has the XPG tenant set to my name. So the contents of your file is just overwrite. Okay. So now that I have set this. I'm again using Mirror here. And now I hope I removed the breakpoint I had set. Um, Not that it matters. Yep. So I'm just going to remove this breakpoint because we don't want it to hit. And I'm just going to run and debug this with Mirror. And we're going to open our terminal till then. Okay, so our code is now running locally. And
Yay.
we are, I mean, it's running. We don't know if it's working, it's doing what we wanted to do or not. So I'm going to send a request to this endpoint. And when I send this request, we see that we get the same response as last time, which is what we were expecting if you're paying attention, because we did not set our HTTP headers. This was just a regular request we sent. Now we want the request we sent to hit our locally running process instead of, the service which is there in the cluster. So I'm going to add the header. Actually, I'm just lazy. So I'm gonna grab the header I had added earlier. So the header is XPG tenant with my name, and now I'm going to send this request. And now this request would hit our process, which has the code where we have changed the response. And if everything worked correctly, we should see the correct response here. Yeah, everything worked perfect. You can see that the response we have gotten here now has a lot of extra information where we can see the tenant, where we can see the timestamp, where we can see time to live, user agents, and all of that stuff. So what happened here was that we sent this request. Mirror saw that the header we had set matched what we had in the configuration file here. And then
Mm.
that request, when it reached the cluster, Mirror stole that request and sent it to our locally running process. Our locally running process populated all the environment variables from the cluster. It got the info from the other microservices which were there in the cluster. It read this file which had these contents remote as front from the cluster. And then it ran our local code which had all these updated fields. And the response sent by it is what we are seeing here right now. So you saw how, because we were using Mirror, we were able to test out the code which Cursor generated for us immediately. Whereas, if we did not use this, we would have to commit this code first and wait for CI pipelines to run and container images to get deployed and to an actual staging environment and then do the testing. And then if something broke, you would have to go through the entire loop again. Here, if you figure out that, like you do not like this high which is appended to here, you can just search for like the code where this is happening and, remove that and test it out again. So it's just that the iteration process with this is so much faster than using like the traditional workflow of committing your code and relying on pipelines and staging deployments, which is what enables teams to just develop faster and have faster feedback cycles. So that was it for the demo. I'm gonna stop my screen share and bring up my
Wonderful. Do we have more
slides
questions?
again. And yeah, I see we have a lot of questions, which is a good thing. Um, so let's see what questions we have. I'm bringing up this. Is it acting as a proxy to the running process? Again, I'm not sure what exactly do you mean by proxy to the running process, but what it is doing is it is proxying the requests between the locally running process and the cluster, including requests for files, environment variables, and traffic. When a vibe coder completes their testing and they are ready to deploy, would they push the application via kubectl? So when you're ready to deploy, Mirror would bring no change to your existing process. So if your existing process is pushing your application via kubectl, then that's what it remains. Mirror happens during the development part of your lifecycle and not during the deployment part. It allows you to test your code faster and have faster feedback cycles, but you do not change how you deploy to production. That still remains the same. if my code communicates with another microservice, will my local machine request be sent to the dev slash prod one, or Mirady will route it to a mirrored one? No, if you're like we saw in this demo, right? The IP visit counter service is talking to the IP info service. So when the locally running IP visit counter service sends a request to the IP info service, that request is sent to the actual IP info service, which is there in the cluster and not a mirrored copy of that service. But when you are using things like databases, we have features like database branching, which allow you to create a replica of that database in case you don't want to write to that particular database. Generally, we run tests locally and then test app functionality on dev and Q and finally deploy to prod. In this deployment cycle, which problem does Mirrorly solve? Can it eliminate the need of any environment? You're exactly right, right? So when you're saying that you test the app functionality on dev and QA environment, with Mirrord, you do not need that. With Mirrord, you don't need to go through that step multiple times. You can just, write code locally and get rid of like multiple dev and QA environments and just have like your staging environment. And then you can test your local code directly against that staging environment. And when you're done, you just go through the normal process of doing that. So you can avoid provisioning dev environments or even multiple QA environments and just have a single shared environment for testing. Say I change the code of two services that communicate with each other over Kafka and I need to test both of them in one go. Can I make them communicate over Kafka without polluting the production Kafka? Yes, you can. So if you're working with multiple services, you just launch multiple, like you just run multiple services using Mirrord. And when talking about Kafka specifically, we have queue splitting, and like I'm gonna show you the Mirrord docs for all of you who have like more detailed questions. So we have queue splitting features which allow you to use like Mirrord with Amazon SQS and Kafka, and then Mirrord takes care of ensuring that when you're using a queue, then like original messages still keep flowing, and the messages you want for development they flow to you when you set the right headers. Did you say Mirrord has features where you can create policies to enforce read-only operations against a database? By the way, Anton, can you see the docs instead of the slides now, right? Because that's what I want to show.
Yeah, we
Just
see the
confirm.
dog.
Perfect. Yes, we have features which allow you to enforce policies to where you restrict certain actions. So if you go to our docs I'm just pointing to the relevant docs pages also so that if you want to look this up later, it's just easier. So we have Mirrord policies which allow you to set rules that writing to a particular database is not allowed, or this user cannot, or users can't perform this particular action. So all of that can be done with the help of Mirrord policies, and this would ensure that when you're in a shared environment that you're not people are not breaking the cluster accidentally. During database query execution, does the query run on the remote cluster or does it rely on local configuration? So if you're executing, like if your process is executing a database query, it will send that request to the database you have in the cluster. So unless you set Mirrord policies, which don't allow it to do, so you can run database queries on the existing class on the existing database which is there in the cluster. But we understand that like people don't want to make changes to the staging cluster, which is why we have this feature called DB branching, which allows you to create a replica of the database and you can work with that replica in case you don't want to touch the main database which is there in staging. Is there a way we can configure which DB to refer to when running Mirrord? Yes, there is a way to do that. You can choose if you want to talk to like a locally running database or the one in the cluster. All of these questions are too detailed, Anton. I feel like we'll have to do another webinar to show all of these cool features people are asking
Okay,
about.
great. People want to learn. We provide the content.
Um, I think I've answered all the questions. We can wait if like people have more questions.
Yeah,
We
we
do.
have another question here.
For integration test suits that try to validate a code change, besides manual testing? Are you seeing many people use Meridian CI pipelines before environment deployment? Does this limit having to make deployments just validate there's a container can safely be integrated? I don't understand the second part of your question, but your first part of question, are you seeing people use Mirrorly, is literally what we launched just like last week. If you go to our website, we just launched Mirrorly for CI, which lets you use Mirrorly in CI pipelines. And it's the same use case, right? Like in CI, also, we see people spinning up ephemeral environments and or using like tools like Minikube and local mocks. But with Mirrorly for CI, we already have customers like Monday.com, which are running Mirrorly in CI, and then they're using it to run tests against their same staging environment, which their developers might also be using for development. So Mirrorly takes care of ensuring that there are no conflicts and multiple CI runners as well as developers are able to use the same shared environment, which allows you to cut down your costs a lot because you are just maintaining one Kubernetes environment for dev testing and CI testing. And also, secondly, it makes your CI run much faster because in the CI, you are just executing your tests against an existing environment and you're not provisioning a new environment or you're not relying on, local mocks or stuff like that.
Okay.
Cool. So let us know.
Looks like,
We're staying
yeah,
on there for a couple of minutes.
there is some interest in using mirror DNCI, and actually it's a use case I would really love to see. So maybe, yeah, we have an idea for another webinar
For sure.
to follow
So
up.
yeah, if you want to learn more about Melody, you can check out our website, metalbear.melody. If you want to check out the project, open source project, try it yourself. We are on GitHub. And if you have any questions, you can personally write to me at this email. Or if you have any feedback on how the webinar was, do you? I have another question. Do you all have already GitHub Actions that can use that? So we don't have GitHub Actions with Mirrorly for CI. If you go to our docs, you don't really need like an existing GitHub action. So there's just a command called mirrorly CI start, and you add this in your pipeline. But if you go to our blog, we wrote about Mirrorly for CI, and there was so this would work for like this is how you would use it in GitHub Actions, right? You get an API key and then you check out your code, you install Mirrorly, and then you just run the Mirrorly CI start command and your test normally. So we don't have a published GitHub action, but you can use it with GitHub Actions if your question
Yeah,
was that.
and it's a great idea for your weekend project. Create an open
Yeah,
source GitHub action for mirror.
vibe coded open source GitHub action for Mirrorly.
Yeah, and then it's not even a weekend project. It's like a
It's
end of day project. Okay. I think this went great, folks. If you still have more questions, we have a couple more minutes to go. If not, then it's fine. And if you have questions after that, reach out to Arsh, reach out to us. This session was recorded. Of course, we'll be sending out a link to it. Feel free to share it with whoever would be interested in using Mirrorly and testing their code, whether AI generated or not on Kubernetes without, negatively impacting the environment. And talking about Kubernetes, let me share my finishing slide. Okay, yeah, here it is. Okay, and yeah, of course, Metal Bear is awesome, Mirrorly is awesome, but this webinar was also brought to you by Perfect Scale. When you run your clusters on Kubernetes, they can, eventually cost you a lot, especially if you want to have those dev, test, staging environments and also multiple production clusters. And it's a very good idea to keep them optimized so that you don't waste CPU and memory, you don't waste resources, you only pay for what you actually need. And that's exactly what Perfect Scale allows you to do. We have quite a mileage in optimizing clusters. We have a community edition. You can go to www.perfectscale.io, sign up free of charge, connect your first cluster, and start getting insights immediately. And you can, of course, scan this QR code and speak with our optimization specialist to understand how you can maximize the benefit of perfect scale for your specific environment. End of the day, it allows you to save your cloud money and to make your applications more performant and more resilient. Arsh, I was very happy to host you today. I think
I
this
thank you for
went
hosting me.
exceptionally well. Everybody can see the value that MirrorD provides to whoever is developing applications for Kubernetes. And yes, definitely let's talk about doing a follow-up webinar, maybe all about MirrorD and CI and stuff like that.
For sure. Thank you for having me, and thank you to everyone who joined. We try to keep it, at a time which is most accessible across all time zones. And I know like it's not like we have people joining from everywhere. So thank you for taking out the time to attend this. And yeah, if you have any questions, feel free to reach out to me at my email or on LinkedIn. See you all.
Bye. Thank you.